Welcome. In this video, we're going to look at assignment, declaration, and initialization. So going back to the last video, we wanted to store this number 3276 in memory. And we knew that this was a 2-byte number at a minimum. So a short would be an appropriate type. Now I've got these big columns and rows of boxes here, and they're all representing bytes. So each box is a byte in memory. And so we could go about and store that number somewhere in memory. Okay? But this isn't such a good idea because how will we know where it is? Okay? Given that this could be gigabytes worth of memory, we don't know where this is in memory, and our program doesn't know. We'll look at some ways to find this memory or know where this memory is right now, and we'll also look at more advanced ways later in the subject. So the first thing we want to do is basically find a space in memory that's suitable for us to store our value. Okay? Because by putting this here, maybe something else is using this memory, and we've just corrupted that. So we need to let the computer decide where's a suitable place in memory, and we also want to give a meaningful name to that spot in memory so that we can know where to store and where to retrieve that information. And this is called declaration, or declaration of a variable. So a variable is just a named location in memory. Okay, it's a little bit different than mathematics, but it has similar properties in the fact that it can change a value. Okay, and to declare a variable, we need the type and the identifier, so the name of the location in memory. So let's do a quick example of this. So I want to create a place to store 2-byte numbers, so I'm going to use a short. And I need to give it a meaningful name. Now, in this subject, it is expected that you have meaningful names, nothing that's overly abstract and that others couldn't understand it clearly. It's called implicit documentation. So don't call variables things like ABC unless you're doing tests or something like that. In a meaningful program, all your variables should have meaningful names. So I'm going to call this my num. Okay, and that gives me a bit of information about what I'm storing. Now, what happens here is we don't have to worry about what's in memory. The computer is going to find us a free 2 bytes in memory, and that could be anywhere. So let's say it picks these 2 bytes here. Okay. Now, that location is now my num. Now, where the identifier is stored, we don't really care about that at this stage of the subject. You can just think of it as having a label for now. Okay, so we've got these 2 bytes that are my num. Now, what value is in there at the moment? A lot of students say nothing or 0, and that's actually wrong. We don't know. Okay, it's unknown. Okay, it's unknown because we don't know what was in there beforehand. So some other program was running beforehand and there would have been something in there, and that program's ended, and so we've just taken that space, and whatever's in there is what's in there. And this is called an uninitialized variable, and we don't want to use an uninitialized variable. So that brings us to our next concept, which is assignment. And this one's very confusing for a lot of students because of the symbol. So I'm going to say my num becomes 3276. Now you would have seen that I said becomes, not equals. This symbol here in C and in a lot of programming languages is assigns or becomes I like using the word becomes. It's a lot easier to say. Um, and what we're basically saying is my num gets assigned the value of 3276, or my num becomes 3276. So at this point, we can now store our 3276 into our memory. Okay? So this symbol here is really important that you understand that it's not the equal symbol. Now, to show you that it's not the equal symbol, we can do something like this. So we can say my num becomes my num plus 1. So here, this is definitely not an equation. Okay, this is definitely not equals. What this is saying is my num becomes the previous value in my num plus 1. So with evaluation, always the right-hand side gets evaluated first, and the left-hand side has to be some storage location. For this subject, it's mostly going to be a variable. Okay. Now, with this, because the right-hand side needs to be evaluated first, the first thing we need to do is go and get our value from my num. And we know exactly where it is because we've got the name. So we know it's 3276, and we've got this addition with a 1. We add them up and we get 3277, and now my num becomes 3277. So we can change that number in binary. Now, with this, there's one other thing that we need to be aware of. So we understand what a variable is. We understand what a variable is. So my num is a variable. Okay, so all of these blue is a variable. Now the other thing we've got to consider is, let me pick a good color, let me pick red, is these here. Now, these are not constants when it comes to C, okay? These are called literals because they're literally the value, okay? It's a bit of a terminology. Constant has a different meaning, and we'll look at constants later, but these are called literals, okay? So these are integer literals. You can have floating point literals, you can have character literals, and so on. These are called literals. Be careful of your terminology here, okay? When it's actually a value, it's a literal. The other things are variables. All right. Now, one thing that we might want to do also, as we said here, when we created my num, we don't know what value it is, okay? And that's not very good because most of the time, I'm just going to set it on the next line because I don't want to have some unknown value. So this is where initialization comes in. So what we do here is we do the declaration and the assignment on the same line. So I'm going to have my num2 becomes 17. And what that'll do is create the location, give it the name, and put the value in there, all on the one same line. So initialization is just these two together on the same line. All right, thank you very much. That's it for this video.